Hey everyone, welcome to ByteBuilder, where developers learn to build with AI. In today's session, we are diving into CrewAI's architecture, the framework that powers multi-agent collaboration. We will explore how agents, tasks, and tools connect under the hood and then bring it out to life in code. Let's get started. When we first start working with LLMs, it's easy to imagine them as so powerful. Ask a single model to code, write, plan, and analyze. It does a bit of everything. But the truth is, one model operating alone can only go so far. It lacks the ability to specialize, delegate, or think across multiple goals at once. Real-world problems like building a search assistant that can plan, gather data, and summarize require distributed intelligence. That's where multi-agent collaboration comes in. CrewAI takes this concept and makes it practical. It gives each agent a defined role, lets them communicate, and coordinates them through a structured workflow. In this video, we will look beneath the surface of CrewAI's architecture, how agents, tasks, and tools connect, and how the framework keeps everything synchronized. A single LLM agent operates in isolation. It has no shared memory, no awareness of other processes, and a very narrow focus. It can generate an answer, but it can't split work or reason over extended goals. For example, if you ask it to research CrewAI and write an article, it will attempt both steps at once, often with shallow results. There's no planning, no role separation, no feedback loop. Think of it like a solo developer trying to build an entire application without version control, testing, or teammates. It works, but it doesn't scale. CrewAI was designed to fix that by introducing structure, collaboration, and communication between multiple specialized agents. At its core, CrewAI is built around three simple but powerful concepts: agents, tasks, and tools. Agents are the actors, individual LLMs or specialized AI entities that perform reasoning or action. Each one has a role, a goal, and a backstory. These parameters give the agent context and personality, so its responses are aligned with its purpose. Tasks are the units of work. They define what needs to be done and which agent is responsible for doing it. Tasks can be anything from gathering data to summarizing insights, writing code, or making a decision. Tools are the extensions that give agents capabilities beyond pure text reasoning. They can search the web, call APIs, read files, or even execute code. When you connect these three layers, agents, tasks, and tools, CrewAI becomes an orchestration engine. It coordinates who does what, in what order, and with which resources. This is what makes CrewAI more than just a wrapper around LLMs. It's a framework for building intelligent systems that think together. Now let's connect the dots and look at the architecture itself. Every CrewAI project has three main components running under the hood. The orchestrator, a central controller that manages the lifecycle of your crew. It assigns tasks, routes outputs between agents, and ensures each agent knows when to act and when to wait. The agents, each defined with a role, a goal, and a memory context. Agents communicate indirectly through the orchestrator, which helps maintain order and prevent message loops. The memory layer. This is what keeps the crew coherent. It allows agents to share intermediate results or retrieve information from earlier steps. In some cases, this memory can be local, persistent, or connected to a vector store. The tool interface. Agents can invoke external functions or APIs as part of their reasoning process. This allows them to not just generate text, but to act in the real world. Together, these components create a structured feedback loop. The orchestrator assigns a task, an agent uses tools to perform it, the result is stored and passed along, and another agent picks up the next task. What's elegant about CrewAI's architecture is that it keeps the coordination logic lightweight. You don't need to manually handle message passing or concurrency. The framework abstracts it for you. This makes it both beginner-friendly and production-ready for more complex agent networks. So far, we have looked at the why and the how, the conceptual and architectural layers that make CrewAI work. Next, we will move into the show me part, setting up a CrewAI project and seeing these components come to life in code. Now, we are going to build a small working demo that shows how multiple agents collaborate to complete a goal. By the end, you will understand not just what CrewAI does, but how it feels to build with it. Now let's start from scratch. Let's first create a directory called CrewAI Architecture Demo. Let's go into it. Let's create a new Python virtual environment. And let's activate our newly created environment. As you can see, our environment is now active. Now that we have activated our new virtual environment, we are going to install our 3 key packages. We're going to use this command. This will install CrewAI, which is our orchestration framework, OpenAI, which provides the language model backend, and Python.env, which will help us securely load our environment variables. Let's execute it. Once the installation has succeeded, you should see output like this. The next thing that we need to do is to create the file in which we are going to store our environment variables. In the .env file, we need to paste this line. Make sure to replace the value with your real OpenAI API key. Also make sure that you never commit this file to GitHub because it's sensitive. The next step would be to create our main.py file in which we will put our logic. Now comes the fun part. Let's open our main.py file and bring our architecture to life step by step. We start by importing 3 core classes: Agent, Task and Crew. These are the building blocks of any CrewAI system. Next, let's define the 2 agents, the researcher and the writer. Here is the code for that. The researcher is our information gathering specialist. The writer is our teacher, turning raw data into readable knowledge. Each agent has a role, a goal and a backstory. Together, these shape how it behaves and how CrewAI prompts the underlying model. Think of it as creating distinct, focused personalities that each handle part of the job. Now let's give our agents something to do. Here are the tasks that our agents will do. Each task defines what needs to be done, what the result should look like, and who should handle this task. Task 1 assigns the researcher to explore how CrewAI connects its components. Task 2 assigns the writer to turn those findings into a beginner-friendly explanation. CrewAI's orchestration will ensure that the writer receives the researcher's output automatically, without you needing to pass data manually. Now, let's assemble everything into a crew. Here is the code to do that. The crew is the orchestrator. It takes our agents and tasks, manages order, communication, and context. When we call crew.kickoff, the orchestration begins. The researcher works first, produces nodes, and the writer continues from there. The process is sequential but intelligent. CrewAI handles timing, data flow, and reasoning steps under the hood. All you need to define is who does what and in what order. Now let's run our code. Let's first open our terminal, type python main.py, execute it, and watch how CrewAI executes the workflow. The terminal first shows logs from the researcher. It shows the output of the researcher, then it shows that the writer agent has been started and the output of the writer agent. Finally, we can see the final output of our agent workflow. Keep in mind that the output will differ slightly each time, but the structure will remain the same. Behind the scenes, CrewAI's orchestrator handled all coordination. It passed the researcher's nodes directly into the writer's task, kept track of context through shared memory, and managed the workflow lifecycle automatically. You didn't have to code message passing, memory storage, or scheduling. CrewAI abstract all of that away. That's what makes this framework powerful. It scales from 2 agents to 20 with the same structure. So in just a few lines of code, we have replicated a complete multi-agent architecture. One agent researching, another writing, both coordinated by CrewAI. You have just learned how CrewAI really works. From the architecture behind agents, tasks, and tools to seeing them collaborate in code. CrewAI orchestrates how agents think together, tasks define what they do, tools help them act, and memory keeps the whole workflow connected. If this helped you understand how multi-agent systems work, make sure to subscribe to ByteBuilder and follow the CrewAI Mastery series. Keep learning, keep building, and keep creating smarter AI systems together.